Hi, ladies and gentlemen, this is Miss Germaine coming to you with the afternoon work for this afternoon. And we looked at today in class. Remember, today was an extension of what we did yesterday. So our activity for this afternoon, we have our learning targets of I can explain why adding or subtracting two equations that share a solution results in a new equation that also shares the same solution. Okay, we talked about the three ways of solving a system. It's all about being strategic. So if you solve something using elimination, you're going to get the same answer if you solve it using substitution. When the reason you're given these three ways of solving is because each one is going to be strategic in its own way. Remember, graphing is good when you have them both in y equals mx plus b form. Also, if you're checking, it's a good way to check. Substitution, remember, is good if we have an equation that's y equals or x is equals. We don't have to do as much work. Or they're also good when you have like almost there type situations, like 5x plus y is equal to 7. Simply move that 5x over to find that y. Easy peasy. Elimination is good when you have them both in standard form. And there's two variables that are semi-close to each other. Or you can manipulate them in some way to get them so that they are a positive and a negative. Okay? So in class today, we just solved some systems. Boom. We had 4 systems, we solved them. Boom. We answered some questions about them. Our afternoon work for today is we have this equation right here. Okay, perform each of the following operations and answer these questions. So for each one of these right here, you need to use this equation right here, add 12 to each side of the equation, add 10 plus 2 to the left side, add 12 to the right, add 4 plus 3 equals 7 to the equation, this guy right here. Okay, what does each resulting equation look like in the blue box? Is it still a true statement? Tell me yes or no in this box right here. Tell me why as well. You're taking 3 minutes right now to do that. I have another minute left. We have 12 more seconds. Okay, so ladies and gentlemen, if we look back to this Zoom meeting right here, let's take a look at the answers that we got here. So if we're looking at this first one here, it said add 12 to each side. So when we look at this guy here and we add 12 to each side, I rewrote my equation on that second line, adding 12 to each of the sides. When you add them all together, combine your like terms, you get 63 is equal to 63. This is a true statement because it maintains equity. Each side is equal to one another. Okay? Awesome job on that one. Now, if we look at B, we added 10 plus 2 to the left and 12 to the right. When I rewrote it, adding my 10 plus 2 to the left and 12 to the right, 50 plus 1 is 51, 61, 62, 63. 63 is equal to 51 plus 12. 1 plus 2 is 3. 1 plus 5 is 1. 63. This is also true because it maintains that equity. Okay? Last one here was add the equation 4 plus 3 is equal to 7 to the equation of 50 plus 1 equals 51. So I added the 4 plus 3 to the left side, the 7 to the right side, and I got 56 is equal to 56. This is also true because it maintains equity. The way that we would look at this is if we wanted to sort of write it, in the style of when we were adding together for a substitution, we could write it as 4 plus 3 is equal to 7, right? And you could write it vertically like this and add them together. So 50 plus 4 is 54, plus 4 is equal to, one second. So 50 plus 1 is 51, 2, 3. So did I add this wrong? 7, 8. Oh, so this is 58. Sorry, Mr. Mean added this wrong. 58 and 58. When we come back together here, we add them together, we get 58 is equal to 51 plus 7 is 58. If you wanted to write it up and down like that. And it's true because it maintains its equity. Okay? So now, second piece of this is, here is the equation 50 plus 1 equals 51. Write a new equation. Then when added to 51 equals 5, gives you a sum that is also a true statement. So you need to write a second equation here that you can add to it that would keep it a true statement. Then explain why it is a true statement. So my example is I add 4 plus 4 to one side, and I add 8 to the right side. Okay, that's my equation. And I'm going to write my explanation in here. What I want you to do is I want you to take 2 minutes right now to write your own equation and tell me why. Wonderful, wonderful. We're taking 1 more minute, guys. And I want to see things just like 4 plus 4 equals 4. Don't make it, come on, make it a little bit challenging. Another 30 seconds. Ten more seconds, my friends. Okay, so let's take a look. So I said 4 plus 4 equals 8. I added that to each side. You could do something like 8x is, oh, let me try that again. No block. 8x plus, or is equal to 3x plus 5x, anything really that would maintain equity. So I said, when I was explaining why, I said it maintains equity by adding the same, and then I wrote number, but then I said to myself, that's not accurate because I didn't really add the same number to each side. When I combined them, it combined to the same number. But when I'm initially looking at this expression or this equation here, it's not adding the same number. So I crossed it out and I said the same value. So when you look at the same, it adds up to the same piece. Value is better because it's implying that you're combining your like terms. So the weight of every single thing that you added, whereas the number just looks at like, what is it worth? The number that you're adding, is it the same to each side? No, it's not. Not necessarily. Value to each side. Now, you're going to write a new equation that when you add it together now is not going to make it true. So this one's going to be a lot more, we're going to have a lot more options for this one. So we're going to say, I'm going to add 9x plus 2 is equal to 7. I want you to take 20 seconds right now to write your own equation that you could add that would make it false. And write why it's not true. And we're going to take another 5. Okay, let's come on back and let's take a look. So I added this 2x, or 9x plus 2 equals 7. I said it doesn't maintain equity because it does not add the same value to each side. And once again, I use this term value because we're talking about how much is it worth, as opposed to just the number itself. Because that word number implies you're adding 4 to each side. You're adding 6 to each side. And that's not always the case. You're adding the same value, which when you combine your like terms is equal to the same weight. Okay? Very good. Let's take a look at the next piece here. So you're going to take 5 minutes right now. You're going to pause the video. Actually, you know what? Yeah, pause the video, and you're going to answer these 3 questions. Why do you think the resulting equation remains true even after we add numbers expression that look different to each side? Suppose we subtract 12 from the left side of this one and subtract 5 plus 7 from the right side. Would the result remain the same? Here's another equation, 50 plus 1 equals 51. Suppose you subtract 12 from the left side, 5 plus 7 from the left of the equation, and 5 plus 7 from the right side. Would the resulting equation be true? Why or why not? Okay, so I want you to take 2 minutes right now to answer these 2 questions. Awesome, awesome. Take another 47. Okay, we're taking another 15 for ourselves, 10 seconds. Okay. So if we look back at these questions here, the first one, why do you think the resulting equation remains true even after we add numbers or expressions that look different to each side? Because we're adding the same value to each side. When you combine your like terms, each side is still equitable. The value of what you're adding is more important than the number itself. Okay, if you were to subtract 12 and subtract 5 plus 7 from each side, would it be true? Yes, it would be true because we are subtracting the same value from each side. Boop, 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 boop. Value from each side. Now we're looking at that same thing and we're asking the question, would the resulting equation still be true? Why or why not? Yes, because we maintained equity, meaning we added the same value to each side. I feel like I'm talking in circles here. Because we're talking about maintaining equity, adding the same value to each side. The term value is so important because using just the word number is not going to be specific enough in this case. Okay, so if we look at slide number 13, okay, so we have the systems of equations. Is there an x or y values that make both equations true? How did you solve the system? And why is it okay to add the expression to x plus y to one side of the first equation, but add 7 to the other side? Okay? I want you to think about these in the context of what we just talked about. I need you to take 2 minutes right now to answer these questions here. Taking another 53 for ourselves. Okay, ladies and gentlemen, let's come back together. Okay, don't know why I just sang, but here we go. Okay, so is there a x and y value, a pair of x and y values that make both equations true. What is the solution to the systems of equations? First, before we talk about that ordered pair, that coordinate pair, let's talk about the way that you solved this guy. Okay, so if you look at this guy, if you look at him, he's a little bit nice if you want to solve it using substitution. But don't make it difficult on yourself. Don't do extra steps. We have a minus 2x and a positive 2x. Those cancel out. I used elimination because it had two variables, the x's, that easily canceled each other out. Okay? They had the same value and opposite signs. That is what that means when we're talking about they cancel each other out. That means that they have the same value, that same number attached at the front, but they have opposite signs, negative, positive. Easily cancel each other out. Use elimination. Use elimination. Okay? Next piece is simply sort of saying, was it okay to add the expression 2x plus 2x plus y is equal to the first side and 7 equal to the other side? And we said, yes, that is okay because they both they have the same value, right? Because there's that equal sign in between them, it has the same value. So you can add them to each other because that is maintaining equity. We can add it to both sides, each piece to both sides because it maintains equity because of that equal sign, okay? Last piece here, we have these two equations here, and we had to solve them using elimination. I have this box right here. Pause this, and you can take a look at it on your own if you need to. So I combine my like terms, divide by 9, 3 equals y, plug your 3 in, solve an x of 2. Okay, so we are finishing this guy up. You're working on the cool down now. So you are looking at slides number 14 and 15, and you are reading through and you are discussing for yourself, what does in the context of the story, what does the solution C comma P represent in the situation? If we add the second equation to the first equation, we have this new equation of 7C plus 8P is equal to 2960. Explain why the same C comma P pair that is a solution to the original equation is also a solution to the new equation. That's what you're doing here. Then the last little bit is number 3 here. You're using this same equation, the same story. Does the equation 7C plus 8P equal 2960 help you solve the original system? And then that's in the first box. Tell me yes or no. And if you think so, explain how it helps. If you don't think so, explain why not and what would help us solve the system. So you're taking the last 5 of your afternoon work today to complete these 2 slides, 14 and 15. You're reaching out to me if you have any questions whatsoever, and I can help you out, okay? Our word for the day, our phrase that you're going to email. So over the weekend, I created this. It's like a mirror, and I put some color on it, and it's kind of hard to see, but I made it so that it sort of looked like a planet. So what I want you to do is I want you to send me an email with 2 things in it. First, my code word, planet, and then I want you to tell me which planet you think is the coolest. I personally think Venus is the coolest, but that's just me. Send me the email with the code phrase. I will see you guys later. Awesome job today. I'll see you tomorrow.